Welcome, Algebra. Today is day 2 of lesson 6.2. We're picking it up on page 145. Today at letter B, we are going to begin our discussion of rotations by going through all the vocabulary. And there is a lot. So the vocabulary. A rotation is a transformation that turns a figure about a fixed point, which is called the center of rotation. The angle of rotation is the amount of rotation that is made, which is measured in degrees, and you have to think of a center of rotation measuring in degrees. You're thinking circle. So the whole circle is 360. So if you remember using your compass and your protractor, this is what might come in handy. You need to understand the direction of the rotation. Like if I'm going to rotate A, which direction am I going to go? I'm either going to go clockwise, like the hands go around a clock, or counterclockwise if the hands would go backwards. Now it says, please look at the diagram at the top of 146. And you see at the top of 146, and I'm just going to move our book right over here real fast. You see a shape, and you see that the direction of this rotation is going clockwise. You see the center of rotation. It's going X amount of degrees, and this thing just keeps its shape, but it just kind of turns and ends there. So that basically is what a rotation looks like. Sometimes we think of rotations like a pinwheel, where it blows in the wind and it just goes around a point of rotation. A wheel would be a point of rotation. We've done things like this in level 6, I believe in level 5 also. Very simple things. Today's lesson is a bit more complicated. Continuing with our vocabulary. In a rotation, the original object and the image, so first figure after it rotates, you got the image. The original object and the image are congruent. Any point A on the object is moved through a fixed angle about a center of rotation to its image at A to the first rotation. The point A and its image A to the first rotation are equidistant from the center of rotation, whichever that may be, and the orientation of the object and that of the image are the same. It's just turning. So now it says, look at the diagram at the bottom of 148. There's one at 147 too. So I know I don't have that on the book, but let's go to 147 first, and then we will go to 148. So on 147, let's see, there we go. We have a rotation of 180 degrees. So basically we are starting here, and it is rotated about the origin. I will tell you this, if you rotate around the origin, which is 0, 0, that is the easiest way to do a rotation. That is the most simplistic way to do a rotation. If that is all we needed to do, we could do this by hand. But you're going to see something that happens that will question what happens here. So anyway, if we're going 180 degrees, notice that angle is, of course, a straight line. So when you rotate it from here to here, B and B are in a straight line, A and A are in a straight line from one another, and C are in a straight line from each other. And of course, the shapes are congruent. They are congruent, and they are orientated correctly, considering if you just keep moving this around. Even though it looks flipped, it's orientated correctly, because if you're just taking this and moving it around a rotation, this does not change. You're not flipping that out as you're rotating. Okay, now if you take a look at page 148 on the bottom, here you see a 90-degree rotation, and it's around point P. Now point P is outside of the shape, so that's kind of like rotating it around a point of origin. And these are 90 degrees. So if you look at point B and point B, and then you take your point of origin P, it forms a 90-degree angle, as does A's and as do the C's. That's where they get the 90 degrees from. So you can see this is a little bit complicated. The one that really kind of blows the mind are the angles of 270. And here their point of rotation isn't outside, so there's no point of origin, it's within the shape. So not only are you trying to figure out how do I rotate 270 degrees, I need to figure out how to do that when my point of origin is here. How do I draw anything? The clue here, the hint here, is what is another rotation equivalent to a rotation of 270 degrees clockwise? Well, it would be 90 degrees counterclockwise, because 270 and 90 make 360, which is the whole circle. And if 270 is going one direction, the 90 would be going the other direction. I'm going to tell you right now at this point, the way all of these problems have been done in this particular lesson, in this textbook, is with a graphing calculator. And they teach how to plug in all of the directions for what you have to rotate into a graphing calculator. They do not do this by hand. Therefore, we are not going to do it by hand either. We are just going to take down these notes. And that's called an introduction. We're going to continue with our notes because the last part is going to be combining all the transformations we have learned to this point. So, before we do that though, going back to just basic rotations. Now, if this is all we needed to do, we could do it by hand. Basic rotations always rotate around the origin. So that would either be around 0 or a point outside of a shape would be an origin too. However, that doesn't always happen, but here's some basic rotations we could actually do by hand. 90 degrees clockwise about the origin maps like this. So your original point is XY. That point would translate or map onto Y negative X. So like if our original point was 3, 4, our next point would be 4, negative 3. So I would take Y and put it in the X position, and I would take my X and add a negative value to it. In this case, it's negative 3. Now, if this were negative 3 and I put my negative value, it would turn to a positive 3 because two negatives make a positive, but you got to keep all that in mind too. Now, if it's 180 degrees about the origin, it would map like this. XY, again, 3, 4. We would just take XY, leave them in, and negate them. Negative 3, negative 4. Now, if this was negative 3, negative 4, of course, a negative and a negative would just be the opposite. So it's whatever these numbers are with the opposites. Okay. If you were to rotate 270 degrees clockwise about the origin, you would have your XY, and then you would flip your numbers. 3, 4 would go 4, 3, but the first one would be negative, or the opposite sign of what it is. Only the first ones. So if you just had it around origins, you could actually figure it out by remembering these mapping rules. And then again, 270 degrees clockwise is the same as 90 degrees counterclockwise. The reverse is true also. 270 counterclockwise is the same as 90 clockwise. So get this all written down. We don't have an occasion to do this, but if you have this written down, you know there is a way to do a simple rotation just by mapping the points, which is always the easiest way to do it. Now we'll go on to combining transformations. We've learned 3 transformations. Last lesson was reflections. This lesson was translations and rotations. The order in which 2 transformations are combined is specific and not interchangeable. So if it tells you one way, you can't flip anything. 2 figures are congruent if there is a combination of reflections, translations, and or rotations, which moves one figure onto the other. There's other ways to determine congruency, but if all you're doing working with the shapes and you don't have measurements, this is the way to do it. That's why measurements are much more precise. We also learn the word tessellation. We've heard that before. Tessellation is a tiling of congruent shapes with no overlaps and no gaps. So if you look at page 151, you see some examples of tessellations. And let's just take a closer look at that. Okay, gotta bend my book backwards a little bit. Okay, here we go. So here's a tessellation, and you see this yellow part and these 2 blue parts, which makes a unit. It kind of makes a unit. And if you look at all of these units, they all fit into each other because a tessellation tiles with no overlap, so they don't go on top of each other, and there's no gaps in between. There's no white spots in between. This is also a tessellation, and it's interesting because if I look at it, I see a square with 4 triangles off of it. And you can also, and these, by rotating slightly, you can get the 4 triangles around a square as you go around, and it makes the neatest pattern. It's just the craziest thing. You can also see like little like tracks with a center in there. It's you can see it all different ways. It's kind of a neat thing. And here you have the letter N and the flip of it, the mirror image of it, and then you have the triangle in between it, and it just keeps going and going and going. Okay, so they give us a site to go to, tessellations. Our assignment today is I want you to look up some tessellations, and with some graph paper, I want you to choose a tessellation that you think you can execute and draw out. As you will see, your graph paper that I'm giving you, or sending home with you actually, because you will be taking this home, this is your Friday lesson, is not huge, because to do a tessellation on the squares that we have would take you forever. So I'm not going to give you a whole piece of graph paper. I'm going to give you a part of a graph paper. And you can get ideas at this website, www.tessellations.org. You can just Google tessellations and look at pictures. I just want you to look at them. Find a tessellation you like and draw it out. And that's your assignment. That is your assignment. When you're done, take a picture, click that green check mark when you're done, and bring it back to school on Monday. Okay, thank you. Enjoy your lesson today.